On today's episode, human spaceflight. Boeing in orbit and Sierra Space moves forward. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Two different crewed launch vehicle systems are in the news from Boeing and Sierra Space. Boeing's much-anticipated Starliner has launched successfully and is in orbit, piloted by Butch Wilmore and Suni Williams. The Starliner was carried into orbit by United Launch Alliance Atlas V rocket from Cape Canaveral, Florida. The most recent delay was caused by a small but stable helium leak in the spacecraft service module, and small helium leaks persist but are not a safety issue. Helium gas is used for propellant pressurization and onboard tankage and has been a favorite for this purpose for decades. Helium has multiple advantages as a pressurization gas. It's non-reactive with fuels, oxidizers and materials in valves, propellant lines and tankage. It's also non-toxic, non-flammable, and is of course light. Helium has only one major disadvantage. The helium atom is very small and it's a monatomic gas, so leakage and diffusion through structures, seals, and membranes is always a factor. This property makes helium the ideal gas for testing the gas tightness of critical equipment such as high vacuum systems, and NASA reports that the currently observed leak rate does not pose a safety risk. But all crewed systems under development in America are expected to shuttle astronauts to and from the International Space Station and are expected to remain docked to the station for months at a time without significant degradation of systems. The Wilmore-Williams test flight will not be of long duration, but NASA and Boeing are using the delay time to study the impact of the helium leak on different recovery scenarios, as return to Earth requires a retrograde burn to drop out of orbit and precise attitude control through the reaction control system for lift vector management to provide a precise landing. The pressure is on for Boeing with the CST-100 vehicle performing a similar function to the proven SpaceX Dragon system, so it's no surprise that both Boeing and NASA are operating with an abundance of caution. An engineering challenge just as serious as getting the spacecraft to work will be controlling costs in the increasingly competitive market for flight-to-orbit services. And a third commercial competitor is gearing up to join the competition, Sierra Space. The company has been developing a lifting body spacecraft, the DC-100 Dream Chaser, under a NASA commercial resupply services contract for space station support. The DC-100 craft, called Tenacity, has arrived at NASA's Kennedy Space Center in Florida for testing ahead of a planned launch later this year. Tenacity is an uncrewed cargo version of the eventual spaceplane and will launch atop a United Launch Alliance Vulcan Centaur rocket. Once eventually certified for crewed operations, the Sierra Space lifting body will compete with SpaceX and Boeing spacecraft for flight to Earth orbit, with NASA developing Orion for exploration beyond Earth orbit. Will there be room for three competitors in this market? Sierra Space has a couple of unique attributes to their design, namely considerable cross-range landing capability with what is essentially a miniature space shuttle, minimizing recovery costs and allowing recovery from a variety of orbits to U.S. runways, and a very gentle 1.5 G re-entry profile, suggesting a ride that could be tolerated by non-professional astronaut passengers or even tourists. But will all three systems survive in a competitive market? It's going to be the most interesting time in human spaceflight since the 1960s. Stay tuned. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.